LightWave 2018.3 update. In this video I will show you most important changes and new features in this update. This update is free for all users with LightWave 2018 license. It is also fully compatible with latest LightWave version. Video is divided into 5 sections. In first part I'll show you new mesh TR system. It is update of previous smart mesh system, and I'll show you why it is important and why it is useful for next versions of LightWave. In the second part I'll show you some new mesh TR tools which are really helpful for modeling from 2D drawings. This is ArcViz part mainly for the users doing a lot of stuff with floor plans and 2D drawings. And in third part I'll show you new tools for NURBS, patches and details. In the fourth part I'll show you non-TR updates, so some tweaks in existing tools. And finally I'll show you what is next after this update. Mesh TR is a next generation of smart mesh engine. It is 100% forward-backward compatible, so you can work on object with mesh TR tools and smart mesh TR tools together without any compatibility problems. It has a new design which removes some technical limits of smart mesh. And all the new tools which are based on mesh TR are with suffix TR. Mesh TR has 3 major new features. First, you can place UV maps on NURBS surfaces. Second, it is multi-thread ready, so some parts of mesh TR are already multi-threaded and some critical parts will be multi-threaded later. And third, speed optimizations. This is mainly because of new design, which is much more simpler. On this screen you can see all basic elements of new mesh TR engine. Some original elements from smart mesh are now divided into special cases. For example, polygon is divided into special case quad and triangle, or NURBS segment which has control point weights is divided into special case of closed segment and B-spline segment. B-spline segment is without control point weights. Same for NURBS surface, which is divided into B-spline surface and closed surface case. Also, original multi-segment curve has special case polyline and a closed curve. And why this is simpler design than previous? Because each this special case has some advantages. For example, triangle is way much more simpler to process than polygon, and it is faster, more stable and more easier to design the algorithm or operation on this special case. And this is valid for all these special cases. Programming and design on these special cases is simpler, therefore faster and more stable. Best visible new feature of mesh TR is NURBS UV mapping. I will demonstrate with new quad UV TR tool. TR suffix means this new tool works with mesh TR. The old version is also here and it is with suffix legacy. Old version doesn't work on NURBS surface. New version can be applied also on NURBS surface, here on this little piece of road. And numeric panel of new version is almost identical with previous version. Only change in this new version is some new advancements. So you can see there is different way how you select grid of the polygons or grid of NURBS surfaces by expanding selection. Just click on the polygons, and selection is automatically expanded. This is much more interactive and better than previous attitude in old version. So this is example how mesh TR tools will be converting the old versions of the tools. There will be always the old legacy version to keep compatibility or possible problems. So you can still revert to old tools. Next chapter is about modeling from 2D floor plans or 2D drawings. First, I'll show you new TR tools, which are very helpful in this process. I'll explain every new tool in detail, and then I'll show you complete pipeline how to use this tool to get drawings with some hidden errors or visible errors, and how to apply these tools and finalize the drawing into surfaces or polygons. Join is a new universal interactive tool for connecting geometry. It is based on previous join command, which is now listed in legacy section, and a new version has two variations. First, join is connecting everything in scene, and second, join edge is connecting only selected edges and curved segments. Both versions are providing the same geometrical operation. Difference is only in selection. There are several geometrical operations unified into join tool, and join tool is going through four basic phases. First, it intersect currently only curves. Then it merge points. Then it removes redundant segments or surfaces or polygons. And finally, it joins segments into curves. And each this phase can be enabled, disabled here in a numeric panel. Now let's try to do some simple examples so you can see how this tool works. First case, two separated line segments. Using join edge, select first, second line, and the 2 points are merged, and final result is one single curve from 2 line segments. Second case, two separated polygons or surfaces. Using again join edge tool, I just need to select this edge or these two edges, and the result is 2 points are merged and 2 edges of polygons are merged into one. Result is both polygons are connected. In third case, we have previous two cases. I will duplicate these polygons, so we will have two overlapped polygons, here just one, and I will duplicate also this line segment. So now we have two line segments, and now I will apply join edge tool, but I will be not selecting. I will use this select all button from the numeric panel. You can do the same in the viewport by holding Ctrl key and clicking into viewport like this. And in this case, all possible edges or segments are selected. Now we can see many things are here. So 2 points, 3 points merged. Here 3 points merged, 2 edges merged, 2 edges merged, 2 edges merged, and 2 polygons merged, and 2 edges merged. If I disable merging, let's say, polygons, you can see these polygons are now not merged. Or if I disable segment, you can disable merging segments. I will leave all options enabled, and the result will be only 2 polygons here, both connected, so that extra polygon was removed, and same for the curve, only single curve with line segments. So these additional options for merging helps to remove unwanted hidden geometry. Next, fourth case is again several polygons, quad polygons, all are separated. In this case, I will show you how might be useful to use join edge selection. So I will join only these two edges, and the result is, if I move this polygon, you can see that only these polygons are merged. So all other polygons are separated, and only these 4 polygons are merged over selected edges, as you can see on this example. Next case is 2 separated polylines, and if I want to join them, I just need to select these 2 segments, because remaining segments are already connected, and this selection is showing you with these dots that these segments are already connected to this selection. So you can select remaining segment, but this has no effect. So result is again single connected line, polyline. With next case, I will show you how join tool can handle some hidden errors. So I will create here additional line segment overlapping, but not full overlap, and one here hidden. And if I use join edge on every edge, and if intersection is enabled, then each segment intersect with each other segment, then additional redundant segments are removed. You can see these 2 and these 2, and the result is clean polyline. So there are no hidden line segment, overlapping segment. This is really helpful if you have a messy floor plan. This option removes a lot of hidden problems without necessity to do it manually. Explode. Explode is a new interactive tool for disconnecting geometrical elements. It is based on a previous explode command, which is now listed as legacy here, and it has also 2 versions, explode and explode edge. First version is applied to all elements in current viewport, and edge version you can select particular edges which supposed to be disconnected. Now let's do some examples with explode tool. In this case we have quad polygons all connected, so if I use explode on everything, then each polygon is separated. I will join it back, and if I use explode edge, let's say on this edge here, then only this edge is disconnected, and if I move it here, you can see that all other polygons are connected. Only this edge along the selection is disconnected. In second example, we have one single polyline. If I use explode to everything, then each segment is separated from original line. So now we have each segment a separate curve. I'll join it back, and if I use explode edge, we have 2 options. We can explode to segments or to curves. So if I use selection, I select these 2 first segments with explode to segments. So all selected segments or edges are separated, each individually. If I use explode to curves, then the whole selection along the curve is separated as an extra curve. So now this is exploded to, this is original remaining of the curve and selection from edge explode. Flat patch. Flat patch is new MeshTR tool for converting 2D drawings into flat surfaces. Flat patch is replacement for previous curve to surface tool, which is still in Create tab and you can still use it. But this new version is mesh TR ready, it is more interactive and way much more optimized. This tool is very easy to use. It creates flat patches or flat surfaces from selected NURBS segments or edges of polygons or edges of NURBS surfaces. So you just select edges and flat surfaces created. You can do it interactively, or you can select all with this button or holding Ctrl key and clicking into viewport. So this is pretty easy, and you can also remove selected curves when there are any, and you can also create patches with holes. Just use this make holes option, and what is more, you can also create patches from background layer. So just select some empty layer, put this into background layer and just select all, and now patches are created from background curves or segments. Modeling from 2D drawings with errors. In this part, I will show you or demonstrate how you can easily convert 2D drawings, floor plan like this, into 3D object as easiest as possible. I will be using a new Mesh TR tool specially designed for this task. This floor plan is from real project and it might have some errors. If you use flat patch directly on floor plan with errors, you get wrong result. So let's try to analyze first. Analyze tool helps you to locate loop disconnections. You can see there are plenty of them. To remove disconnection, best way is to start with join tool, which is automatic, and it will remove. First it will connect, merge, intersect and remove redundant. You can make custom threshold, change from default to higher value, and you can see something more is adding into, but don't go too high because with higher values you can remove some detail from object. So now we joined everything, merged, and all automatically possible errors are removed now. So let's go to analyze tool again, and we have still some disconnections, but if you inspect these disconnections, you can see all of them are visually detectable. So these cannot be, these are not hidden, these cannot be removed automatically. In this phase, if you have too many of these errors, sometimes it is better to recreate floor plan with a wall tool or line tool from scratch based on this floor plan, but there are not too many of them, so we will remove remaining errors manually. So I will explode everything into segment, and with help of analyze I will locate all these problems and delete them. And last one here, nothing to remove, we need to extend, and after extension we need to cut these original lines. So let's do with join tool again, which intersect automatically. So the last phase before using flat patch would be always join with full settings. And now when we use analyze tool again, the floor plan is completely clean, so nothing disconnected, no loop disconnection. Now we have clean floor plan. We can use flat patch tool, apply to all segments, and don't make holes for this kind of floor plan, and remove selected curves, and done. And this is final flat patches. So you can see everything perfect. To finalize these to 3D, just select floors, all floors, move it to second layer, go back to remaining walls and extrude them with extrude tool. And that's it. And 3D is done. NURBS patches and detail. In this chapter, I'll show you new exciting tools for creating NURBS patches and editing detail on the NURBS. First, Edge Refine tool is for low-level adjustment of detail along NURBS surfaces and NURBS curves. Patch is universal tool for creating patches from anything. Terrain is new experimental tool for generating NURBS patches as a terrain. Then quads to patch is tool for converting between quads and patches back to quads. And soft edge is for removing hard edges between NURBS patches. Edge Refine. This is completely new tool in LightWave and it is dedicated to adjusting level on NURBS surfaces and curves. It has three basic modes. Select edge mode, you can deselect current edges or curve segments, and then you can add and remove nodes. When you add nodes on this curve, you're making it more smoother. This operation is NURBS refinement, so you're adding more control points, more level of detail. You can do reverse operation, so you can remove node. And this operation can be destructive if you remove significant node, which is crucial for shape of the curve. So if I remove, let's say, this original node, you can see it changed curve shape. So you can add more nodes on the curve without destroying shape, but a remove node can be destructive. Same works very well also on closed segments, and you can do same operation also on NURBS surfaces. So just select edge, and in case of surfaces, if you select one side of the edge, then opposite side is automatically selected because it is how NURBS surfaces are working. So now you can also refine NURBS surface, and then you can remove these nodes. This operation is fundamental operation of the NURBS, and this will be advanced more with next versions. For this tool, there will be additional tool for automatic node removal. So you just set some threshold, and these insignificant nodes will be automatically removed. Additional options here are you can show control points, you can show node values, and you can also normalize node values. I have to show you this on this curve here. So if you select edge and node values are not in the interval 0 to 1, you can normalize with this option. So now everything is from 0 to 1. Same for the closed curve. Patch tool. Patch is universal tool for creating NURBS patches from curve segments or surface edges. It is substitution for several existing known tools like loft, closed loft, rail along single or two segments, cordon patch and network patch. Each this mode is automatically switching this tool depend on how you select these edges or NURBS segments. Now let's do some basic cases of using patch tool. First selection is most important because you define starting segment, and it depends on which end of the curve or segment you click, because this click defines also orientation of this segment. So for this case, railing segment along a single curve, you have to click from opposite side of the railing curve to define direction this way, and then second selection of V railing curve, it doesn't matter because it is already aligned to fit original selection. Next case is railing curve along two railing curves. So I'll start here, this is starting segment, and then again doesn't matter which side you define because V segment is automatically oriented to starting U segment. Next case is lofting case. Here we doesn't have V segments, so we just select U segments, nothing is connected. So just drive with mouse over this curve and patch is created. It's easy. Next case is again lofting, but in this case I will enable closed U option, and now we create closed loft object with this option. So this is another method. Next case is classic Gordon patch created from 4 connected curves. You can start as railing along single segment, then select also end segments and second railing curve, or you can start as a loft from U to U and then define side curves. So result is always same. Finally, network patching. This is most complicated, and all these railing curves along U and along V, each must be single segment, not divided, and each crossing between these railing curves must be touching. These railing curves must be touched in these points. One of the easiest way how to do this is to use spline tool with the UCS disabled, and in perspective viewport I just connect these ends with new segments. In this case you see this point, this point, this point, everything is snapped on these railing curves, and this way you can create proper network of railing curves. And now just apply patch tool. So I'll start as a loft, patch along U segments and select also V segments, and patch is properly created, fitting all these network curves exactly. This is mathematically correct, and each segment of railing curve is lying directly on surface. Terrain patch. This tool is just experimental tool to demonstrate how patches can be created from geometry. If you are Acquis user and you have some inputs for creating patches from clients, please use support and send us object whatever you have, and this tool can be accommodated to real data from real projects. So you can, for now you can play with this tool and you can generate some terrains, but it's not very much tested with real data yet. So terrain patch works with two modes. It can interpolate points or it can be placed on object. So by clicking on top viewport I create, let's say 7 to 8 or 2 or more, 10 to 10 segments patch, and now you have two ways. you can fit existing points from this mesh in background. So now patch is trying to fit these points, or you can try to project this patch terrain with ISO points. ISO points are here, these points, to existing geometry. So these are two different methods, and you can get different results. Here we have a result terrain. Again, if you are Acquis user and you have some inputs for these terrains, please send via support and make this tool better. Quads to Patch is interactive tool for converting polygonal quads into NURBS surfaces and back. This tool is a replacement for previous Quads to NURBS tool, which is still here listed in Create tab. But this new version is way much better. You can interactively add a selection of quads and expand this. This is same tool as Quad UV Mapper, new Quad UV Mapper. It works very user-friendly, and tool can handle very well also closed surfaces. So you can create closed NURBS patch from quads, and it works also backwards. So let's say I will create this patch, and then second use I will convert it back. You can use select all option by clicking into viewport and select back, forward, backward. Soft edge. This new tool is for removing hard edges between NURBS patches. So first I will create some NURBS patches which has some hard edge, as you can see here, and if you use soft edge on this case, then it removes this hard edge by moving neighbor points to the edge on the surfaces. So the edge is now soft. You can set also which side of the surface or which side of the edge, which surface will be modified. So if I disable this side, only left side is modified to remove this hard edge, or other side. Another way how to use this tool is to change the detail of surfaces before you use soft edge. So let's say I will select these two edges here, and if you add knot and change level of detail around this edge, so let's say one knot here, one knot here, and now when you apply soft edge, the softening part is much smaller. So this way you can change how this tool will create this softening area together with Edge Refine tool. In final chapter I will show you new updates and tweaks which are not related to new Mesh TR system. First update is in line. When you using light as a spline, interpolating through the selected points, you can disable spline smooth ends. If spline smooth ends option is disabled, then number of control points is exactly matching number of handles. So this is the true interpolated spline. If you enable spline smooth ends option, then there are some extra control points on the beginning and end of the spline. This way it is much more user-friendly or modeling-friendly spline, but the number of control points doesn't fit to number of handles. Both modes might be useful in different cases. Next update is in projection snapping in Snap Panel. Here we have new option for maximum projection points. With these options, only certain number of projection points are active, and you can set this value, let's say, to 3. Then if you're adding projection points, then only last 3 points are active and the older ones is deleted. Then we have 3 additional modes which you can mix and match. So perpendicular means you can snap perpendicularly to projection point. Tangent means you can snap with tangent on projection point, and ortho is orthogonal snapping to projection point. This new update is much more reasonable and much more clear than previous. And finally, we have some updates in drag and weight tool. It works same way on dragging points, but you can see some visual change. The previous version is also visible. This might help a lot. And we have some new options in numeric panel. First, edge points can be set to single or dual. What does it mean? If you are dragging body of the edge or curve segment or surface edge, then you can set how many control points will be modified. In case of NURBS segment, single means you are dragging only nearest control point. If you are dragging edge, only nearest control point of the edge is modified, and in dual mode you are modifying 2 nearest control points. So if I touch NURBS surface here, I am dragging nearest 2 control points. In case of edge of the, let's say, NURBS rectangle or polygon or surface, then 2 points of the edge are modified. So this is the difference. And additionally, we have some constraining options. If you are holding Control key or in Snap Panel you have set angle snapping, this constraining mode is applied for drag and weight. So in case of perpendicular constraint, I will be holding Control key and you are constraining dragging of the segment perpendicularly to this NURBS segment, or tangent, or ortho x, y, z, let's say z. And if I try this, let's say on the perspective viewport, with perpendicular, I can touch now also polygons and flat surfaces. So with perpendicular constraint, or with let's say here X ortho, and finally we can use this constraining on NURBS surfaces. So let's say I want to modify this testing terrain and adjust height of some areas on this terrain. I will use constraining along y-axis and holding Control key. Now you can very beautifully adjusting this terrain. Also, if I set constraining to perpendicular, then it will be modified perpendicular to this surface. So you see, in the direction of the point where you touch this surface. So this is very useful when you need to do some tweaks on surfaces or polygons in perspective viewport, this constraining. In final chapter, I want to discuss about what you can expect in the next version. Please be aware that this is just preliminary list of tools. Some, if not ready on time, will be moved into next version. So next version 2018.5, it's free update and there will be round TR, offset TR and extrude TR. These are critical tools and these tools must be done into absolute perfection. Next year we are starting with next LightWave cycle 2020 and there you can expect new road tool using Mesh TR system, also new projection tools for placing geometry on NURBS surfaces on mesh, then next 4 basic edit tools for dividing, for welding, for reducing and for freezing Mesh TR, and some new Archviz tool for generating gutters, placing walls to the edges, and many more tools are in the list. I hope this video was useful and helpful for you, and if you have any more questions, please use LightWave support or forum. Thank you for watching.